Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course, Patch Management. It is not wise to go running around the network randomly updating computers, not to say that you would do so. Patching, like any other process, should be managed properly. Patch management is the planning, testing, implementing and auditing of patches. Now these 4 steps are ones that I use. Other companies might have slightly different patch management strategy, but each of the 4 concepts should be included. Planning. Before actually doing anything, a plan should be set into motion. The first thing that needs to be decided is whether the patch is necessary and whether it is compatible with other systems. Microsoft Baseline Security Analyzer (MBSA) is one example of a program that can identify security misconfigurations on the computers in your network, letting you know whether patching is needed. If the patch is deemed necessary, the plan should consist of a way to test the patch in a clean network on clean systems, how and when the patch will be implemented, and how the patch will be checked after it is installed. Testing. Before automating the deployment of a patch among 1,000 computers, it makes sense to test it on a single system or a small group of systems first. These systems should be reserved for testing purposes only and should not be used by civilians or regular users on the network. I know this is asking a lot, especially given the amount of resources some companies have, but the more you can push for at least a single testing system that is not a part of the main network, that less you will be blamed if a failure occurs. So I just want to move this down here. Okay, implementing. If the test is successful, the patch should be deployed to all necessary systems. In many cases, this is done in the evening or over the weekend for larger updates. Patches can be deployed automatically using software such as Microsoft's SCM and third-party patch management tools. Auditing. When the implementation is complete, the systems, or at least a sample of the systems, should be audited first. Make sure the patch has taken hold properly, and second, to check for any changes or failures due to the patch. SCCM and third-party tools can be used in this endeavor. Group policies, security templates, and configuration baselines. Although there are important tasks, removing applications, disabling services, patching, hotfixing, and installing service packs are not the only ways to harden an operating system. Administrative privileges should be used sparingly, and policies should be in place to enforce your organization's rules. A group policy is used in Microsoft and other computing environments to govern user and computer accounts through a set of rules. Built-in or administrator designed security templates can be applied to these to configure many rules at one time, creating a secure configuration. Afterward, configuration baselines should be initiated to measure server and network activity. To access group policy, go to the run prompt and type group policy edit.msc. This should display the local group policy editor console window. Figure 4.7 shows a typical example of this on a Windows client. Although there are many configurations you can make, this figure focuses on the computer's security settings that can be accessed by navigating to local security policy, computer configuration, Windows settings, security settings. From here you can make changes to the password policies. For example, how long a password lasts before having to be changed, account lockout policies, public key policies, and so on. We talk about these different types of policies and the best way to apply them in future chapters. The group policy editor in figure 4.7 is known as the local group policy editor and only governs that particular machine and the local users of that machine. It is a basic version of the group policy editor used by Windows Server domain controllers that have Active Directory loaded. It is also from here you can add security templates as well. Security templates are groups of policies that can be loaded in one procedure. They are commonly used in corporate environments. Different security templates have different security levels. These can be installed by right-clicking security settings and selecting import policy. This brings up the import policy from window. This technique of adding a policy template becomes much more important on Windows Server computers. Figure 4.8 shows an example of import policy from a Windows server. So there you go there. There are three main security templates in Windows Server. DEFLT base.inf uncommon, DEFLTSV.inf used on regular servers, and DEFLT.DC.inf used in domain controllers. By default, these templates are stored in system root INF among a lot of other INF files. Select the policy you desire and click open. That establishes a policy on the server. It's actually many policies that are written to many locations of the entire local security policy window. Often these policy templates are applied to organizational units on a domain controller, but they can be used for other types of systems and policies as well. In Windows Server you can modify policies and add templates directly from Server Manager, Server Configuration Wizard as well. If you save templates here, they are saved as .xml files instead of INF files. Group policies are loaded with different group policy objects, GPOs, by configuring as many of these GPOs as possible. You're implementing OS hardening, ultimately establishing host-based security for your organization's workstations. Baselining is the process of measuring changes in networking, hardware, software, and so on. Creating a baseline consists of selecting something to measure and measuring it inconsistently for a period of time. For example, I might want to know what the average hourly data transfer is to and from a server. There are many ways to measure this, but I could possibly use a protocol analyzer to find out how many packets cross through the server's network adapter. This could be run for 1 hour during business hours, of course, every day for 2 weeks. Selecting different hours for each day would add more randomness to the final results. By averaging the results together, we get a baseline. Then we can compare future measurement of the server to the baseline. This can help us to define what the standard load of our server is and the requirement our server needs on a consistent basis. It can also help when installing additional computers on the network. The term baselining is most often used to refer to monitoring network performance, but it actually can be used to describe just about any type of performance monitoring. Baselining and benchmarking are extremely important when testing equipment and when monitoring already installed devices. Any baseline deviation should be investigated right away. In most organizations, the baselines exist. The problem is that they are not audited and analysed often enough by security administrators, causing deviations to go unnoticed until it's too late. Baselining becomes even more vital when dealing with real-time operating systems, RTOS. These systems require near 100% uptime and lightning fast response with zero latency. Be sure to monitor these carefully and often. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.